Historically, a head turn, sometimes interchanged with the term plurothotonus, has been considered an indicator of abnormalities affecting the forebrain. Plurothotonus describes the twisting of the head, neck, and trunk to one side, while a head turn involves only the head and neck. Other terms used to describe similar postural deviations include torticollis, laterocollis, and scoliosis. The study aimed to identify other regions within the central nervous system that could cause a head turn, whether the head turn occurs in isolation or with other postural deviations. The study was a multi-center observational prospective one, conducted across 6 veterinary referral centers. 49 client-owned dogs presenting with a head turn were included. These dogs had photographic or video evidence of a head turn, underwent a full neurological examination, and received advanced imaging such as magnetic resonance imaging or computed tomography for lesion localization. The researchers recorded the side and degree of a head turn, as well as any concurrent body turn or head tilt. The dogs were categorized into subgroups based on imaging results: forebrain, brainstem, cerebellum, or cervical spinal cord. Cases were excluded if structural changes were not identified, if multifocal areas were seen, or if one lesion affected multiple subregions. The results of the study indicated that a head turn is not exclusively associated with forebrain disease. Of the 49 dogs, 24 had lesions in the forebrain, 9 in the brainstem, 9 in the cerebellum, and 7 in the cervical spinal cord. Different disease processes were identified in these locations, including interaxial masses, ischemic infarcts, extraaxial masses, and non-traumatic hemorrhages. Interestingly, the researchers found different combinations of head and body postures based on the imaging location. Of the dogs with a head turn only, the majority had forebrain disease. Brainstem cases often presented with head tilts in concurrence with a head turn, while cervical cases commonly had a head tilt and body turn in combination with a head turn. In cerebellar cases, head tilts were often contralateral to the lesion. In almost all cases of forebrain disease, the head turn was ipsilateral to the lesion. A concurrent body turn was also ipsilateral in these cases. Other signs of forebrain involvement included altered mentation and behavior, compulsive circling, and proprioceptive deficits. In dogs with brainstem disease, the head turn was ipsilateral in all cases, with many showing a head tilt. A correct lesion localization based on the neurological examination was achieved in most cases. Other signs included proprioceptive deficits, changes in mentation, and nystagmus. For dogs with cerebellar disease, all head turns were ipsilateral to the lesion, and most had a contralateral head tilt.